I want you to picture uh, the most famous mathematical constant, like really picture it.
Oh, it's got to be the one from middle school geometry, right?
Exactly, yeah.
Yeah.
You're sitting there, the teacher draws a circle on the chalkboard, draws a line right through the middle, and introduces you to this, this magical, never-ending number, pi.
3.14159 and just on and on into infinity.
Right. And you've probably got it memorized to at least a few digits, right?
Yeah.
I mean, we see it everywhere.
Oh, absolutely.
It's in our textbooks. It's fundamental to the engineering of the bridges we drive over, the architecture of the buildings you walk into, and crucially, it is baked into the fundamental equations that physicists use to define the universe itself.
We just trust pi completely.
Yeah. We rely on pi to tell us how reality works.
Yeah.
But what if it's a century-old mistake?
Wow.
Yeah. What if pi, this foundational pillar of human mathematics and physics, is actually just like a geometric artifact, a kind of mathematical hallucination?
It sounds almost heretical, doesn't it, to call pi a hallucination?
It really does.
Because pi is just so deeply ingrained in how we view reality. If you take a physics class, from high school mechanics all the way up to, like, quantum field theory, pi is treated as an absolute truth.
Right, an unquestionable law.
Exactly. But the premise we are exploring today challenges that at the very root. I mean, the idea is that we only use pi because we assumed the universe is shaped a certain way. Specifically, that it is perfectly round and smooth.
And if that assumption is wrong,
If that assumption is wrong, then every equation built on top of it for the last 100 years is essentially describing a mirage. We have been, mapping a shadow, thinking it was the object itself.
which brings us to our mission for today's deep dive.
Yeah.
We are going to completely tear down the sphere.
Yeah.
We are going to look at what happens when you just rip pi right out of the equations that govern light, out of Einstein's gravity, out of the strong nuclear force.
And replace it with something completely different, right? Yeah.
Exactly. The golden ratio. And only after we see the math perfectly balance will we really grasp the magnitude of the document we're looking at today. It's a 2026 paper by George James Dukas titled End of Pi in a Phi Universe.
And this is part of a larger framework, right? The transdimensional unified field theory.
Yeah, TDUFT for short. Our goal today is to understand how replacing pi with the golden ratio, along with this tiny modifier called the emergence deficit, completely rewrites physics from the ground up, with absolutely zero free parameters.
Let's hover on that phrase for a second. Zero free parameters.
You explain that for us.
So in standard physics, a free parameter is essentially a manual tuning knob. It is a number we have to physically measure in a lab and then just sort of plug into our equations to make them work.
Because the theory itself can't predict it.
Exactly, yeah. The mass of an electron, the strength of gravity, these are free parameters. We just accept them. But what this framework claims is that there are no tuning knobs at all. None. The geometry itself dictates the physics perfectly. But to even begin to visualize how that works, we have to throw away this image of the universe as a smooth, continuous, perfectly isotropic void.
Right, because isotropic just means it looks the same in every direction.
Yeah.
Right, like standing in the middle of a perfectly uniform fog.
That's a great way to put it. Yeah. We have to completely discard that fog. The text provides a totally different conceptual backdrop. It describes the vacuum of space not as a smooth, continuous fluid, but as a discrete 64 tetrahedral lattice.
Okay, let's unpack this. A 64 tetrahedral lattice. If I'm trying to picture the empty space in the room I'm sitting in right now, I shouldn't be picturing an empty box, right? Are we talking about something like a cosmic honeycomb?
A cosmic honeycomb is a great starting point, actually. But instead of hexagons, think of interlocking pyramids, tetrahedrons.
Okay, interlocking pyramids. Got it.
And it is incredibly structured. It has pentagonal symmetry. The visual imagery provided with the source material really captures this. I mean, picture these radiant golden phi symbols, that elegant Greek letter for the golden ratio nested within recursive geometric galactic spirals.
Oh, wow.
Yeah, it looks like a living, breathing fractal made of light and geometry.
It sounds beautiful, honestly, but also incredibly rigid compared to a smooth void.
It is rigid, but it is also self-similar across scales. The universe, in this view, is a cascading fractal built on the golden ratio, spiraling from the absolute smallest quantum scale all the way up to, like, the scale of superclusters of galaxies.
Which brings us to the first massive hurdle, the great spherical mistake, as the test essentially positions it. Because to say pi is a mistake, we really have to understand how it got the job in the first place.
Wait, why is it even there?
Exactly. Why did pi enter physics at all if the universe is actually this interlocking geometric lattice?
Well, it is all about the history of geometric assumptions. If you go back to the early theorists, the pioneers of electromagnetism and gravity, when they were trying to model how things work.
Like how a light bulb radiates light, or how a planet pulls on a moon.
Yeah, exactly. They assumed that fields radiate outward in perfect spherical shells, like dropping a pebble in a still pond and watching the circular ripples expand.
Right.
They assumed the vacuum of space is that smooth pond. So if you assume a field radiates as a sphere, what kind of math are you going to reach for?
You're obviously going to grab the math of spheres, and the math of spheres fundamentally requires pi. The circumference of a circle, the surface area of a sphere, it's all pi.
Precisely. The text points out that Maxwell's equations for electromagnetism, Coulomb's law for electric charges, Einstein's general relativity curvature tensors, even the vacuum integrals in quantum electrodynamics,
They all pi.
they all contain pi. But here's the critical distinction. Pi was never derived from first principles in these physical laws.
Wait, really?
Really, it was inserted. It was a mathematical consequence of a geometric assumption.
So it's kind of a self-fulfilling prophecy. You assume the universe acts like a sphere, you use spherical math to measure it, and surprise, surprise, pi shows up in your answer.
Exactly. It's a closed loop of logic.
But here is where I have to push back, because I can hear you, the listener, thinking it too. Pi has worked. I mean, we launched satellites into orbit, we split the atom, we built the GPS networks that navigate our cars, all using physics that relies heavily on pi.
Right. It's undeniable that it produces results.
So if it's a mistake, how on earth is it getting the right answers?
That is the million-dollar question. And the paper addresses it by explaining the concept of a macroscopic approximation.
A macroscopic approximation. Right?
Yeah, pi works well enough because it serves as an approximation for phenomena that are expressed through radial geometry over very large distances. If you are doing conventional continuum physics...
Meaning you are treating space as a smooth fabric because you are zoomed out so far, you can't see the individual threads.
Yes, exactly. Pi is going to appear to work in that scenario. But a continuum is just a macroscopic projection. It is a smoothed out average.
Okay, let me try an analogy here. Let's say you were trying to calculate the square footage of a perfectly cubic room. But the only tool you have is a round tape measure, and you have been taught your whole life that rooms are spherical.
Okay, I like where this is going.
So you measure the radius from the center, you crunch the numbers using pi, and you get an area. It might actually be close enough that you can go to the hardware store and buy roughly the right amount of carpet to cover the floor.
Right, the carpet fits, mostly.
Exactly, the carpet fits. So you pat yourself on the back and say, my spherical room theory is correct. But you are fundamentally misunderstanding the shape of the room. You have the carpet, but you don't actually understand the architecture.
That is a phenomenal way to put it, yes. Pi is effective in the continuum approximation, just like your round measurement gives you a workable approximation for the carpet.
But it fails at the fundamental level.
Completely.
Yeah.
It completely fails to describe the discrete, fundamental structure of the vacuum itself. The vacuum, according to this framework, is not continuous. It is a lattice.
With distinct interlocking parts.
Right. Pi cannot describe a recursive lattice. Pi describes continuous circles. Phi describes discrete dimensional geometry and recursive self-similarity.
There is a quote from the text that I want to dig into because it gets right to the heart of this.
Yeah.
It says that pi is a transcendental number, but phi squared is algebraic. In this theory, phi is squared to produce phi and psi.
Yes, the fundamental operators.
But why does an algebraic foundation make more sense for a physical, tangible universe than a transcendental one? Because to a layperson, those just sound like two different flavors of math.
It is a profound distinction, actually. Think about what a transcendental number actually is. Pi goes on forever, 3.14159 into infinity, without ever falling into a repeating pattern.
Right.
And importantly, it cannot be the root of a simple algebraic equation with integer coefficients. It implies a kind of smooth, infinite, unbroken continuum that doesn't actually fit a quantized physical reality. A physical universe has limits, it has pixels, it has fundamental building blocks.
So a transcendental number is like infinitely smooth, formless clay. You can just keep zooming in forever, and it never resolves into a building block.
Exactly. An algebraic foundation, built on phi, implies that the universe is constructed from discrete, solvable geometric operations.
It means there is a fundamental unit, a structural grammar.
Yes. The golden ratio, phi, is the solution to a very simple quadratic equation. x squared minus x minus 1 equals 0.
Okay.
It is a specific, solvable geometric proportion. It is the difference between trying to build reality out of infinitely formless clay versus building it out of distinct, interlocking geometric bricks.
Okay, so if the smooth clay is out and the interlocking bricks are in, we have to talk about the new foundational rules. Because the text introduces a new trio that runs the universe, completely replacing the old constants.
The new operating system.
Yeah, the new OS. First we have phi, which it defines as expansion or velocity asymmetry. Then we have psi, which is temporal contraction or time asymmetry.
Right.
And then there's this third component, epsilon. The text calls this the emergence deficit, and it gives it an exact non-negotiable value. 0.002075442. What exactly is an emergence deficit?
This is where the theory gets incredibly concrete. In this framework, the universe has to pay a tax whenever abstract geometry becomes physical reality.
A tax?
Yeah, epsilon is that tax. It is the universal emergence deficit between a perfect geometric maximum and a physical manifestation.
So, like, reality isn't perfect.
Right. Think of phi as the geometric blueprint, the theoretical maximum of how things should expand perfectly in a mathematical void. But to actually manifest that geometry into physical space and time, to push it through that 64 tetrahedral lattice we talked about.
A tiny bit of potential is lost to friction.
Exactly. That loss is epsilon.
And the text applies this directly to the speed of light, which, I mean, absolutely blew my mind. Because in classical physics, we just use empirical measurements for the speed of light.
We just observe it.
Yeah, we shoot a laser in a vacuum, we measure it, we get roughly 300 million meters per second. We just write that down in our textbooks as c. We don't know why it is that number, it just is. It's one of those free parameters you mentioned.
But TDUFT actually derives it from scratch.
Yes, and it derives it perfectly using this epsilon tax. The text provides the formula. The physical speed of light, c, is exactly equal to the geometric maximum of 3 minus the epsilon deficit, multiplied by 10 to the 8th meters per second.
Right, just the number 3.
Just the number 3. 3 is the theoretical geometric maximum for dimensional propagation.
Okay.
But light isn't traveling through a pure, frictionless math concept. It is ratcheting through a physical lattice. It pays the epsilon tax.
Oh, I see.
Yeah. So 3 minus 0.00207542 equals 2.9979245.8, which, when multiplied by 10 to the 8th, gives you exactly 299,792,458 meters per second. The exact measured speed of light.
That is wild. Let me make sure I'm wrapping my head around this. Imagine the universe as a pure mathematical grid on paper. On paper, light wants to travel at exactly 300 million meters per second. That is the geometric ideal. Right. But because reality isn't paper, because it's this rigid interlocking lattice, light has to physically grind its way through these geometric tetrahedrons.
Yes.
And every time it moves, it pays this tiny friction tax. So the speed limit of the universe isn't some random number we just happen to roll. It's the literal cost of doing business in a physical geometry.
That is an excellent translation of the mechanics. The speed of light is completely dictated by the dimensional ideal and the emergence deficit.
Yeah.
Pi is nowhere to be found. And if space itself isn't a smooth sphere, but this recursive lattice governed by phi, psi, and epsilon, well, that changes everything. It forces us to ask, how have we been misunderstanding things as fundamental as magnetism or gravity?
Right, which takes us directly into the crosshairs of James Clerk Maxwell and Albert Einstein. Section 2 of our deep dive really dismantles Maxwell and the illusion of curvature in gravity.
Let's start with Maxwell in the 1860s. He gave us the equations for electromagnetism.
Right.
His constants, mu0 for magnetic permeability and epsilon 0 for electric permittivity, dictate how light and magnetic fields propagate through the vacuum. And both of those constants are absolutely loaded with pi.
But TDUFT rips pi right out of them.
It has to, because, again, Maxwell assumed that fields radiate in spherical shells. His constants are built on the assumption of spherical radiation and spherical vacuum impedance.
Think about what permeability and permittivity actually mean. They're essentially measures of how much resistance the vacuum puts up against electric and magnetic fields. Maxwell modeled that resistance, assuming the vacuum was a uniform spherical fluid.
But wait, aren't permeability and permittivity just measured facts? If we measure the resistance of the vacuum in a lab, and the math says it has pi in it, How can we just take it out?
Well, we aren't changing the measured reality. We're changing the geometric language used to describe it.
Ah, okay.
TDUFT replaces Maxwell's continuous constants with pure operator ratios based on phi, Ti, and a dimensional operator called d. So the electric storage capacity of the vacuum isn't some arbitrary number with pi in it. It is defined strictly as an operator ratio. Phi squared times d squared.
And magnetic resistance.
Magnetic resistance is defined as phi cubed divided by psi squared times d to the sixth.
Okay, so instead of using a number that assumes a smooth sphere, we're using algebraic constructions to describe how a lattice stores and resists energy.
Exactly.
Like the difference between calculating the flow of water through a perfectly smooth pipe versus calculating how water trickles through a filter made of interlocking geometric crystals.
Precisely. They are algebraic, they are geometric, they are derived, and they are completely pi-free. And when you put these new phi-based constants together, they still produce that exact speed of light ceiling we just talked about.
Wow.
But they do it without ever assuming the vacuum is a sphere.
So if I am trying to visualize electromagnetic waves, like, I don't know, the Wi-Fi signal hitting my phone right now, I shouldn't be seeing ripples on a pond radiating outward in perfect circles.
No. You should be visualizing a discrete, recursive geometric lattice responding to gradients. The lattice itself is twisting and transferring energy from one tetrahedron to the next.
Like a physical handoff.
Yeah, it is a phi recursive operation, a mechanical handoff, not a continuous circular wave.
If rewriting Maxwell wasn't enough to shake things up, the text goes straight for Einstein next.
Yeah.
General relativity, the bedrock of modern astrophysics.
This is where it gets really crazy.
Yeah. Einstein's gravitational coupling constant, the math that tells us how mass bends space, relies heavily on pi. It's the famous 8 pi g over c to the fourth power. The text says Einstein assumed spherical vacuum energy density and circular geodesics. But then the author just drops the hammer. The text bluntly states, curvature is complete nonsense as a fundamental mechanism.
I mean, that is a direct attack on the most famous physics metaphor of all time. The bowling ball on a trampoline.
It is a complete paradigm shift. Einstein's geometric machinery fundamentally assumes spherical curvature. The entire framework of general relativity is based on the idea that mass acts like a heavy bowling ball, bending the continuous trampoline-like fabric of space-time into a curve.
And that this curvature is what we feel as gravity.
Right, but TDUFT says the vacuum isn't a continuous fabric, it's a rigid lattice.
Yeah.
It cannot curve in the smooth, continuous way Einstein described. Therefore, the curvature we observe is an illusion.
Okay, I have to stop you there. Because I can see and feel gravity.
Sure.
If I drop my pen right now, it hits the desk. The planets orbit the sun. If it's not the bowling ball curving the trampoline of space-time, what is actually pulling the pen down? What is gravity in a phi universe?
The text describes curvature as an emergent artifact. Think of it as a shadow.
A shadow.
Yeah. And what is casting that shadow? Density gradients projected from higher dimensions. In the TDUFT framework, gravity is not a literal curve in a 3D space. It is a density projection.
A shadow from a higher dimension. Okay, that sounds a bit like sci-fi, so let's ground it. Are you saying that what looks like a curve to us is actually just a concentration of geometry?
Let me use an analogy. Imagine shining a flashlight on a translucent 3D object, like a glass sculpture of a funnel.
Okay.
The shadow it casts on a 2D wall looks like a flat circle that gets darker in the middle.
No.
If you were a 2D creature living on that wall, you would measure that shadow, notice the gradient of darkness, and say, ah, my 2D space is curving inward here.
But it's not curving.
Right. You are just experiencing the density of a higher dimensional object projected onto your reality.
Wow. So we are the 2D creatures measuring a shadow, thinking the universe is bending, when really it's just getting geometrically denser.
Yes. And because of that, the text collapses. Einstein's complicated 8 pi g coupling into a shockingly simple operator identity. It says the g, the gravitational constant, is simply 1 over t to the fourth power, where t squared is density.
Wait, I need to make sure I heard that right. Einstein's equation has pi, the speed of light to the fourth power, the gravitational constant, and TDUFT says g is just 1 over t to the fourth,
Yes.
where t is just the time operator, psi. That's it.
That is it. The left side of Einstein's famous equation, which represents geometric curvature, mathematically goes to 0 in this framework because continuous curvature isn't fundamental.
Wow.
The right side of the equation, the stress energy tensor, which represents mass and energy, becomes a pure density operator, t squared. Pi vanishes completely. Spherical geometry vanishes.
So what are you left with?
What you are left with is gravity as a pure projection of time contraction, which concentrates geometry, resulting in physical density.
Gravity is just time contracting space into denser pockets.
Yeah.
That is elegant, but it raises a massive unavoidable question.
Which is,
Where does this density, this physical mass actually come from? If everything is just emerging from these geometric operators, phi and psi, how do you get a physical particle? How do you get a physical heavy bowling ball out of purely mathematical instructions?
that is exactly where the source material takes us next, and it is arguably the most fascinating and historically rich part of the text. It brings us to the operator gate, and it completely demystifies the work of the physicist Paul Dirac.
So Paul Dirac. The text positions him as the first physicist to accidentally discover the operator reality of this phi universe way back in 1928.
Yeah.
Specifically, he discovered the psi gate, which is the exact mechanism where abstract geometry literally becomes physical mass.
Yeah.
Let's set the stage for Dirac because his famous equation is legendary. He was trying to reconcile quantum mechanics, which deals with tiny particles, with special relativity, which deals with things moving very fast.
Right. And to make the math work for an electron, his equation did something bizarre. It produced negative energy states, which required a negative mass term containing a -1.
And mathematically, this involves something called spinor inversion.
Okay, stop right there. Spinor inversion. We need an ELI 5 for that, because that sounds like heavy jargon. What is a spinor?
Okay, imagine holding a coffee cup in your hand, palm facing up.
All right, got it.
Now try to rotate that cup a full 360 degrees without taking your hand off it or spilling it. Your arm gets twisted, right?
Yeah, my elbow's in a weird spot.
Exactly. You're back to where you started with the cup, but your arm is in a weird state. To untwist your arm and return your entire body to the starting state, you have to rotate the cup another 360 degrees.
Okay.
It takes 720 degrees of rotation to return to the true zero state. That underlying twisting mathematics is essentially what a spinor describes in quantum mechanics. It's a deeper geometric reality where a simple 360-degree rotation isn't enough to come full circle.
So Dirac is wrestling with this twisting spinor math, and out pops this -1 in his mass equation. Historically, physicists have just treated that -1 as a mathematical necessity, right? A quirky requirement to make the algebra balance out, which famously led Dirac to predict the existence of antimatter.
Yes. For a century, it was viewed as an algebraic trick that happened to map to reality. But TDUFT says that -1 isn't just a mathematical placeholder or a trick. It is a literal geometric instruction embedded in the universe.
And here's the reveal.
Yeah.
TDUFT claims that -1 is the multiplicative closure of the golden ratio and its conjugate. The equation is phi multiplied by psi equals -1.
Phi times psi equals -1. Let's break that down. Phi is the operator for expansion.
Right.
Psi is the operator for temporal contraction. When you multiply the force of expansion by the force of contraction, they close the loop. They lock together. And that locking mechanism, that -1, is what Dirac stumbled over.
I want to really visualize this. The text describes a dimensional ladder. You have different tiers of reality. D2 is the photon tier. It has geometry, it has energy, light is zipping around, but it has no mass.
It weighs nothing.
Exactly. Then you step down to D3. D3 is the physical mass tier. This is where things get heavy.
And Dirac's equation sits exactly on the border between D2 and D3.
Oh, wow.
It is the exact moment where the universe steps down a dimension, or rather where the geometry condenses into something solid. Dirac sits precisely at the boundary where the contraction operator psi forces the expanding waves to stop multiplying and start adding geometrically.
And that's what creates mass.
When you apply that psi operator, you manifest mass.
It's like freezing water into ice. The water is the geometry in D2, fluid and massless. The psi operator is the cold temperature.
Yes.
When it hits, it forces the water molecules to lock into a rigid, heavy crystal mass in D3. And Dirac essentially found the freezing point.
That is a brilliant way to conceptualize it. The text argues that Dirac replaces Einstein's curvature as the true quantum gate.
Einstein was looking at the macroscopic shadow of gravity, the big clumps of ice.
Right. Dirac actually touched the hinges of the door where the water turns into ice, where matter enters physical reality.
There's an incredible irony in this.
Yeah.
Dirac is staring at this -1 in 1928, realizing it predicts antimatter, but he has no idea that the -1 is actually phi times psi I.
He had no clue.
He didn't know it was the golden ratio wrapping back around on itself to create a physical boundary. He mapped the door perfectly. He saw how it opened without ever knowing what the door was made of.
It is the defining tragedy and triumph of 20th century physics. These brilliant minds building incredibly accurate mathematical models based on shadows and incomplete geometric assumptions.
Okay, so if Dirac shows us how a single pixel of mass pops into existence at the quantum level through this phi and psi interaction, how does that scale up? Because a planet isn't just one pixel of mass, it's billions of them.
Billions and billions, yeah.
And more importantly, how do these newly manifested masses interact with each other in space? If gravity isn't the continuous curve of space-time, how does a sun hold a planet in orbit?
That brings us to section 4, rewriting the cosmos orbits without conics. If you look at classical orbital mechanics, going all the way back to Johannes Kepler in the 17th century, it inherits pi directly from Euclid's circles.
Right, because when we map an orbit, we use radians, we use conic sections, we measure circumferences. We view an orbit as an ellipse, which is essentially just a squished circle, and circles mean pi.
Exactly. Kepler formulated his laws of planetary motion inside that circular Euclidean framework. He assumed the planets were cutting through space in geometric ellipses.
So pi appears in orbital equations not because nature requires it, but because Kepler assumed the geometry was based on conic sections, slices of a cone.
Right, and the TDUFT orbit equation completely removes pi and conic eccentricity. It throws out the idea of the stretched circle entirely.
Let's look at the new orbit equation the text provides. It defines the radial coordinate of an orbit as a function of phi and psi. Okay, lay it on us.
The equation is the radius equals phi squared plus psi times the cosine of the angle, all divided by 2 phi times the reference radius. I know that's a mouthful of algebra for an audio format, but the crucial takeaway is what isn't in that equation.
No pi.
There are no trigonometric circumference terms. There are no transcendental constants like pi.
None, because an orbit is not a conic section. It is a phi ellipse. It is governed entirely by that golden ratio dilation pair we just talked about.
So phi and psi are doing all the work.
Exactly. Phi controls the orbital dilation, the expansion, how far the planet swings away from the star. Psi controls the contraction, the time progression that pulls it back in. And their multiplication, that phi times psi equals -1 identity, is what produces the correct orbital path purely algebraically.
Here's where I need to expand on an analogy, because reading an equation doesn't really help us visualize it. The text calls the orbit a harmonic deformation of a circular baseline. It made me think of an audio synthesizer. Oh, interesting. Walk us through the synthesizer analogy. How does that translate to a planet in motion?
Okay, if you have ever played with a synthesizer, you know you start with a carrier wave, a baseline pitch, just a steady, unmoving hum.
Right.
In TDUFT, that baseline is fixed entirely by phi, Ci, and the reference radius. It's the stable mathematical center of the system. But to get a complex sound, a wobble, you introduce a low-frequency oscillator, an LFO.
You modulate that baseline.
Exactly. You combine the carrier wave with a harmonic frequency. In orbital mechanics, Ci acts like that LFO. It supplies the oscillation, the pulling in and letting go, while phi supplies the radial closure.
So they work together to create the shape.
Yeah, you are harmonically modulating the baseline to create a physical shape in 3D space. You aren't tracing a geometric circle, you are harmonizing these expansion and contraction operators.
That is a remarkably accurate visualization. The orbit is a harmonic deformation of the closed phi-psi radius. It is an active, dynamic process, not a passive path traced in a void.
It really changes how you picture the solar system.
Completely. And this completely transforms how we understand Kepler's third law, too. Classical Kepler III is a pi-squared based formula that relates how long a planet takes to orbit to its distance from the star. TDUFT transforms this into a pure fitted to the sixth power divided by a density gradient projection.
No pi squared, just fit to the sixth.
Yes. The entire concept of an orbit is redefined as a pure phi-psi operator derived from that universal quadratic equation we mentioned earlier, x squared minus x minus 1 equals 0.
The golden ratio roots.
Exactly. That equation gives you the roots of the golden ratio. The universe is literally just solving that simple algebraic equation dynamically, over and over again, tick by tick, and the resulting physical manifestation is a planet orbiting a star.
It is incredibly elegant. It strips away all the messy, infinite decimal places of pi and leaves you with a clean algebraic machine.
It really does.
We've seen how phi governs these massive celestial bodies in space, but we need to zoom all the way back in. What about the absolute smallest, tightest spaces in reality?
The atomic scale.
Right. What happens when we look inside the atomic nucleus? Because the text next takes us into quantum chromodynamics, the strong sector, and the Planck units.
Quantum chromodynamics, or QCD, is the theory that describes the strong nuclear force, the incredibly powerful force that holds quarks and gluons together inside protons and neutrons. And QCD just like relativity, is absolutely saturated with pi.
And I think I know why now. Let me guess. Spherical assumptions again.
Right.
Why is pi hiding inside a proton?
You guessed it. It's the exact same Euclidean assumptions. When physicists were building QCD, they assumed spherical momentum shells. They used circular Fourier transforms to move between position and momentum space.
Let's pause on Fourier transforms for a second. To put it simply, a Fourier transform is a way to deconstruct a complex signal into its basic frequencies.
Right.
Like taking a smoothie and mathematically figuring out exactly how many strawberries and bananas went into it. But the math they use to do that deconstruction relies heavily on sine waves and circles, hence pi.
Exactly. They calculate phase space volumes, which is basically a mathematical map of all possible states a particle could be in assuming a continuous isotropic vacuum.
And that fog again.
Yeah, the fog.
Yeah.
Every loop integral, every renormalization constant in QCD relies on continuous circular geometry.
And TDUFT says, stop doing that. The strong sector is not a continuous smooth field.
Right. It says the strong interaction is not a gauge field living on a smooth manifold. TDUFT replaces all of this continuous math with a discrete full lattice torsion cohesion process. The vacuum inside the nucleus is just a highly structured, intensely packed version of the same 64 tetrahedral lattice.
Torsion cohesion. Torsion means twisting. So instead of a smooth field radiating spherically to hold quarks together, it's more like the geometric lattice itself is twisting and physically binding them.
Like wringing out a wet towel.
Yes, like wringing out a wet towel until it coils back on itself into a tight knot.
Yes. It is a torsion gradient on the phi lattice. The geometry is literally twisting tighter to hold the mass together. And when you model the strong force as discrete lattice torsion, you do not need spherical momentum shells.
Because it's not a sphere.
Right. You don't need continuous sine waves. Therefore, you do not need pi. The text explicitly states that pi is removed from every strong sector quantity. Loop integrals, beta functions, cross-sections, decay widths, all the pi terms are stripped out and replaced by phi gradient operators.
This all culminates in how the text handles the Planck units. For the listener who might not know, Planck units are essentially the absolute foundational units of measurement in physics. Planck time, Planck length, Planck mass.
The pixel size of the universe.
Exactly, the smallest possible meaningful measurements. And historically, they are all derived using constants that contain pi, especially the reduced Planck constant, which relies on 2 pi. But TDUFT strips pi out of all of them.
Completely. It redefines the pixel size of reality using the operators we've been discussing. Planck time simply becomes t, which maps to the time operator ci. Planck length becomes d, the dimensional ladder operator.
And Planck mass.
Planck mass, which classically is a terribly messy square root involving the gravitational constant and the speed of light, simply becomes d cubed times t squared.
Wait, Planck mass is just a dimension cubed multiplied by time squared, d cubed times t squared. I have to put myself in the shoes of a skeptical listener here.
Sure, go for it.
If we strip pi out of Planck action, which historically relied heavily on 2 pi to define the very quantum of action, and we just replace it with this algebraic string, d to the 5th times t, do we lose the physics? Are we just shuffling letters around on a chalkboard and losing the actual predictive power of the equations? If I build a bridge with this math, does it fall down?
It is a crucial question, and it's the right pushback. But the text is emphatic. The physical meaning remains entirely intact. The bridge doesn't fall down. We are not losing the physics. We are correcting the underlying geometry that the physics was built on.
Okay, give me an analogy.
Think of it like translation. If you write a recipe for a cake in French, and then you translate it perfectly into English, you haven't lost the cake. The ingredients are the same, the baking time is the same. You have just removed the French vocabulary.
Pi is the French vocabulary in this scenario.
Yes, pi is the Euclidean vocabulary. TDUFT translates the physics into the native language of the universe, which is the phi-psi operator codex. The equations still balance, the speed of light is still exact, but the artificial scaffolding of continuous spheres is gone.
We're shedding the scaffolding.
Yeah.
That makes sense. We still have the cake, we just stopped pretending we baked it in a spherical oven. Seeing this pi-free reality across every discipline, from the macro scale of gravity to the micro scale of the strong force, it really forces a moment of reflection. We have to look back at the giants of physics, the people who spent their entire lives, their brilliant Nobel Prize-winning careers, working within the wrong geometry.
That is the focus of the final section of our text, the legacy of the spherical assumption. The text does a review of the titans of 20th century physics. Albert Einstein, Paul Dirac, Richard Feynman, Frank Wilczek, Stephen Hawking, and it points out that every single one of them inherited pi from the mathematics of Euclidean geometry, not from nature itself.
Let's talk about Richard Feynman. He is famous for his path integrals and loop diagrams in quantum electrodynamics. He basically wrote the rulebook for how particles interact. The text says his integrals are heavily reliant on 2 pi.
Yes, every loop integral in Feynman's work uses a 2 pi to the 4th power normalization factor. Why? Because he was calculating probabilities over continuous circular momentum space. He was assuming the particle could take any infinite smooth path.
But TDUFT changes that.
TDUFT replaces those continuous loops with torsion induction channels on the discrete lattice. The particle isn't swimming in a smooth pool, it's ratcheting through a rigid grid.
And Frank Wilczek, who won the Nobel Prize for his work on the strong force in QCD, the text notes that his phase space equations and beta functions are completely saturated with pi and Stephen Hawking. Hawking's most famous formulas, the temperature of a black hole and the formula for black hole entropy, they both contain pi.
Because Hawking was modeling the event horizon of a black hole as a perfect continuous sphere. He was using spherical horizon geometry and Euclidean curvature to calculate how radiation escapes it.
Which TDUFT says is impossible.
Right. TDUFT says if you replace that continuous horizon curvature with a torsion density threshold based on the T operator, the psi contraction, the pi disappears entirely. The black hole isn't a sphere, it's a zone of maximum lattice density.
It is awe-inspiring, really. When you step back, you realize that a single, unverified assumption, the idea from antiquity that space acts like a smooth sphere, cascaded through over 100 years of genius-level calculations.
It's incredible.
There is a deep tragedy and a massive triumph here. The triumph is that these physicists were so brilliant, they built incredibly accurate models anyway. They managed to make the math work to predict reality with astonishing precision. Pi worked well enough in those macroscopic continuum projections to give us modern technology.
Right, they made the carpet fit.
They did. But the tragedy is that they were ultimately modeling a shadow. They were working so hard to make the spherical carpet fit the cubic room without realizing they were inside a lattice.
If we connect this to the bigger picture, the implications for the future of science are staggering. For decades, fundamental physics has been somewhat stuck. We have been building larger and larger particle colliders, spending billions of dollars to smash protons together at higher and higher energies, hoping to find a new exotic particle that will magically unify relativity and quantum mechanics.
We're just hitting things harder and harder.
Exactly. But TDUFT implies that we don't need a more massive collider. We do not need a higher energy scale. We just needed to fix the foundational geometry of the math we were already using.
We were looking through the wrong lens. We were looking for spherical answers in a pentagonal phi-recursive universe.
Exactly. And once you swap the lens, once you replace pi with phi, psi, and epsilon, the unification happens naturally. The text claims this yields a unified geometric foundation with 0 free parameters. It connects gravity, electromagnetism, and quantum mass emergence through a single, elegant operator codex.
It fundamentally changes how we perceive the space we occupy right now. It means the empty space between you and the device you are listening to this on isn't an empty, smooth void.
It's alive in a mathematical sense.
Yeah, it is a vibrating, recursive lattice of golden ratios, taxing energy to create the speed of light, twisting to hold your atoms together, and projecting density to keep you anchored in your chair.
It is a highly active geometric machine. It is not an empty stage. It is the actors, the script, and the stage all at once.
Okay, let's bring this all together. We have gone deep into George James Ducas's 2026 framework. We have seen how pi is arguably a geometric artifact, a shadow born from the ancient assumption of spherical symmetry.
We covered a lot of ground today.
We really did. We explored the claim that the true universe operates on a recursive, pentagonal 64 tetrahedral lattice. We saw how phi governs expansion, how psi governs time and contraction, and how the emergence deficit epsilon acts as the friction tax that dictates the exact physical speed of light.
We saw how this completely removes pi from Maxwell's electromagnetism, from Einstein's relativity and the illusion of curvature, from Dirac's mass emergence, from Kepler's planetary orbits, and from the strong nuclear force inside the atom.
Which is just staggering to think about.
It replaces continuous, infinitely smooth curves with discrete, algebraic, geometric operators.
It is a complete rewrite of the universe's operating system. And it leaves me with one incredibly provocative thought that I want you, the listener, to mull over long after this deep dive ends.
All right, what is it?
If the greatest minds in physics, Einstein, Feynman, Hawking, Dirac, If they spent a century seeing circles where the universe was actually drawing golden spirals simply because they inherited the geometry of the ancient Greeks, what other fundamental truths in our science, our biology, or even our digital algorithms are just artifacts of the tools we invented to measure them? Are we actually seeing reality for what it is, or are we just staring at the shape of our own magnifying glass?
That is the ultimate question this text demands we ask. Once you see the lattice, you really can't unsee it.
Thank you for joining us on this deep dive into the source material. We hope it encourages you to look a little closer at the shapes around you and to question the fundamental geometry of everything you've been taught to accept as true. Keep diving deep.